वेलकम टू सहायक एजुकेशन। सहायक एजुकेशन में आपका स्वागत है। 10th क्लास के मैथ्स की सीरीज के अंदर आज हम बात करेंगे सर्कल्स के बारे में। सर्कल्स जो कि एक बहुत इंपॉर्टेंट चैप्टर है और दिस इज द 10th चैप्टर ऑफ 10th स्टैंडर्ड। विदाउट वेस्टिंग टाइम लेट्स स्टार्ट विद द चैप्टर। फर्स्ट ऑफ ऑल, इट इज द 10th चैप्टर ऑफ 10th स्टैंडर्ड एंड दिस चैप्टर कंटेन्स अराउंड 6 to 7 मार्क्स इन बोर्ड एग्जाम्स। तो अगर आप प्रिपेयर करते हैं 6 to 7 मार्क्स आपके पक्के हैं। ओके, इफ यू गो थ्रू द entire video from beginning to the end, you will be able to gain 6 to 7 marks minimum. Now, what is a circle? होता क्या है circle? Okay, we have talked about circle from our childhood, but do you know what a circle means? So the definition of circle is the circle is a locus of all points equidistant from a given point. मतलब एक पॉइंट आपको दिया हुआ है, उस पॉइंट से इक्वल डिस्टेंस पर, उस पॉइंट से इक्वल डिस्टेंस पर आपने मान लिया कि 3 सेंटीमीटर दूर है या 4 सेंटीमीटर या कुछ भी आपने मान लिया, उस डिस्टेंस पर जितने भी पॉइंट्स हैं, दिल बी मिलियंस एंड मिलियंस और बेसिकली इनफाइनाइट नंबर ऑफ पॉइंट्स। अगर आप उन सारे पॉइंट्स को ज्वाइन कर दें, तो हम उसको सर्कल बोल देते हैं। सो दे आर सेइंग दैट द सर्कल इज द लोकस मींस ऑल द पॉइंट्स टुगेदर इक्विडिस्टेंस फ्रॉम गिवन पॉइंट। इससे इक्वल डिस्टेंस पे, मान लो ये 3 सेंटीमीटर था तो ये भी 3 सेंटीमीटर, ये भी 3 सेंटीमीटर, एवरीवेयर जस्ट 3 सेंटीमीटर। वो सारे पॉइंट्स जो भी एक सिंगल पॉइंट से इक्वल डिस्टेंस पर हैं, अगर हम उन सबको ज्वाइन कर दें, दैट विल मेक अ सर्कल। So this part is clear. So the circle is a locus of all points equidistant from a given point. Now, अगर हमें इसको सीखना है, okay, if you want to learn about this circles, then there should be certain terms, very simple terms, which we should remember about the circle. Now, what are those terms? The first term comes out to be center. Now, what is the center of the circle? See, हमने बोला कि circle के अंदर locus of all point equidistant from a given point. That given point is called center. So this is center, and then comes the circumference. This line which is we are making, which is equidistant from that particular point, that is called circumference. So this is center and this is circumference. So center is the point around which the circle is made, and circumference is actually the circle. The line of the circle is called circumference. Then come radius. So radius is the distance of the center from the circumference. So this is represented by r. Radius is the distance of center from circumference. So this is radius. We know everywhere on any side we can make it the radius. The center, the distance from center to the circumference is called the radius. Then comes chord. What is a chord? Okay, now if I make a circle and join any two points on the circumference, my line might not be correct, but so if I join any 2 points on the circumference, that will make a chord. Okay, it could be here to here, it could be here to here, it could be here to here, anywhere. So if I join 2 points on the circle, so 2 points on the circle means on the circumference, if I join those, that will make a chord. Then comes diameter. What is diameter? Diameter is the longest chord. It's a longest chord. It's the longest chord in a circle, and it passes through center. It passes through center. Okay, and it is 2 times the radius. See, from here to here is the radius. This is the radius, and this is also the radius. So it is 2 times the radius that we know. From center to circumference is radius, center to circumference is the radius, and so this becomes the diameter. This becomes the diameter from one side to the other side. So it is 2 times the radius, you know it. It passes through center. Yes, it is passing through center, and it is the longest chord. So in exam, they can ask a half-mark question stating what is the longest chord in a circle called dash. It's a diameter. Okay, then comes what is an arc. So when we make a circle, the part of a circle, if you take this part, so what is this? This is like this. So this part, it is not making a complete circle. It is a part of the circle. It's a small part of the circle that is called an arc. So any part of the circle, it could be a big arc or a small arc. Okay, it could be like this. This is an arc, or it could be this. This is an arc. This is an arc of a circle. The arc of a circle should have one point which is equidistant from it. Basically, it is a part of the circle. If we cut this chord from here to here, so this will make an arc of this kind. Is it clear? Okay, coming to central angle. Now, if I just clear it up, what's a central angle? So if I take this as an arc, or basically this is the complete circle, and in the complete circle, if I take 2 points and make an arc, so this is an arc here. This is an arc. So this arc will be subtend some angle. Basically, it will make some angle at the circle. So if I join this and join this, so this is making an angle at the center. So this angle at the center is called the central angle. This angle is called the central angle. Okay, so what the angle subtended by an arc at the center is called the central angle. Now, segment. I just clear it up. So what is a segment? Now, if there is a circle and there is a chord which is cutting, this is a line which is cutting it. So the circle is getting divided into 2 parts now. So this part will be called as a segment, and segment means it's a part of, and this part will also be called as the segment. So it is divided into 2 segments then. Now, because this is smaller, this side is smaller, so we'll call it a minor segment. It's called minor segment. And this part is bigger, we call it major segment. Okay. So if a line is cutting the circle into 2 parts, it is dividing it into minor segment and major segment. Now, clearing up, coming to next, sector. What does the word sector means? Say, if I make a circle again, and in the circle, from the center, this complete part makes the sector. Now, this is one sector. Now, I can say this is a bigger part, which is also making something. So this is also sector. So this is also sector. And this one is also sector. But the smaller one will be called as minor sector, and the bigger one will be called as major sector. Okay. So sector is inclusive of, basically it's a pizza ka piece hota hai. जैसे पिज्जा का पीस होता है ना, तो एक पिज्जा का पीस इज अ सेक्टर. You can remember it by that. Now comes the term semicircle. Okay, semicircle क्या होता है? Semicircle is half circle. So if we make this circle like this, the half of circle is called semicircle. So this is semicircle. Okay, so basically it is a sector which is half of the circle. It is a sector which is half of the circle. That's called a semicircle. So how many semicircles we can make in a circle? 2. We can make 2 circles. So basically it's getting divided by a diameter. So this is the diameter. This is the diameter from this point to this point. It's getting divided by a diameter. So semicircles, we can make 2 semicircles. This is one semicircle. This is another semicircle in a circle. Okay, so coming to other terms, lines and circles. So first one is the non-intersecting line. Non-intersecting line means So there is a circle and there is a line which is not intersecting with the circle. So there's a circle and there's a line and they're not intersecting. They're not cutting each other. They're not intersecting or with each other. They're not even touching. That is the first case. This is the first case. Second case could be a tangent. Tangent is when a line is touching the circle at one point. When the line is touching the circle at one point, that's called a tangent. And in this chapter, we'll be talking about tangents a little more. Then the third thing comes as secant. The secant is a line which is dividing the circle into two segments. This is the minor segment and major segment. So it is cutting the circle, or it is intersecting the circle at 2 points. It is intersecting the circle at 2 points. Okay. Here, zero interaction. Here it is touching once, and here it is touching twice. It is intersecting twice. Okay, so here is the, so when we make a tangent, in tangent, the point where it touches the circle, is called point of contact. Where it touches the circle. So there is only one point of contact when there is a tangent. So here you can see there is one point of contact. For other also, you can see there is only one point of contact. So there is only one point of contact in cases of tangent. And please remember, there is only one tangent at a point of the circle. At any point on the circle, we can have only one tangent. अगर ये point है, तो यहाँ से सिर्फ एक ही tangent cross करेगी जो इस point पे touch कर रही है. So coming to next, the tangent at any point of the circle is perpendicular to the radius through the point of contact. So this is a theorem. Theorem, what does it say? That the tangent at any point of the circle is perpendicular to the radius through the point of contact. What does it mean? It means that अगर आप एक tangent बनाते हो, so this is the tangent. This is the tangent which is given. Now this will be perpendicular to the radius. So center say, if I touch that point from point of contact, this is the point of contact. So tangent will make an angle of 90 degree with the radius at point of contact. So हम radius अगर point of contact से बनाते हैं, point of contact पे अगर हम radius बनाते हैं, then it will make a 90 degree angle with that. So this is a theorem. Okay, you have to remember this part. Okay, so how to prove it? To prove it, what we are going to do, we are going to make one point M. Say this is the point M. Okay, and we don't know whether it is making 90 degree angle here or not. We don't know. Okay, we don't know that here it is making a 90 degree angle or not. Okay, so we know that a perpendicular is the shortest distance. Perpendicular is the shortest distance between a point and the line. Perpendicular is the shortest distance. Now let's say it's making a perpendicular from point M. Now point M will be OS plus MS. So this is OS and then MS. So OS and MS. So that means OS plus MS. Okay. This is the distance between M and O. So if we are considering that, okay, there is another point M with which O is making, or basically the O is making a perpendicular. So let's take the point as M. And when we draw this point, it comes as OS plus MS. Okay, but we know that OS is equal to OT, because that is OS and OT are same. OS is equal to OT. That means OS plus MS will be greater than OT. So if OS plus MS is greater than OT, okay, that means this line OM is greater than OT. That means we can say that OM is not perpendicular. OM is not perpendicular. OM is not perpendicular to line AB. Perpendicular. So which one is perpendicular? OT is perpendicular, or we can say OT is the shortest. OT is the shortest distance, and that's why it is making a perpendicular from O to T. Now coming to the next, it says the length of the tangents drawn from an external point to the circle are equal. They're saying that if there is a point P outside the circle, and if we make two tangents, so because if there is a point outside the circle, it will make two tangents. It will make maximum of two tangents on the circle. And they're saying that the length we have to prove, or it's a theorem, that PQ is equal to PR. We have to prove it. I just said to prove in the theorem. As such, we can take it, but we have to prove it. Okay. Now, how to prove this point? Now, we know that OQ is equal to OR. Yes or no? Both are radius. Both radius. So this is equal to this. We know that. We also know that this angle is equal to 90. This angle is also equal to 90. So I will say angle OQP is equal to angle ORP. Okay. 90-degree angle. And we also know that OP is equal to OP. Common. So triangle OPQ is congruent to triangle OPR. Why? Why they congruent? By right angle hypotenuse side congruency. By RHS congruency. So if these are equal, if these two triangles are congruent, we can say that PQ is equal to PR by CPCTC. Congruent parts of congruent triangles are equal. CPCT. Okay. CPCT लिख देते हैं. Congruent part of congruent triangles are equal. CPCT. So coming to next. Oh, now the questions. Exercise 1. How many tangents can a circle have? A circle can have, you tell me. How many tangents a circle can have? This is one circle. This is one tangent here. At this point. This point. How many tangents a circle can have? A circle can have infinite number of, every point of the circle can have a tangent. That means infinite number of tangents are possible on a circle. At any point, there will be only one. If they would have asked at any point, then the answer would have been only one. But if they asked how many tangents can have, that means we can have multiple infinite number of tangents. Okay, for the next question. Oh, a tangent to a circle intersects in how many points? A tangent to a circle intersect it in how many points? A tangent intersect only at 1 point. Okay. Second intersects at 2 points, but tangent intersect only at 1 point. The line intersecting a circle in 2 points is called a secant. A circle can have dash parallel tangents at the most. It can have 2 parallel tangents if there is one tangent which is already given. If there is one tangent which can already be given, then there will be only one tangent which will be parallel rules. It will be 2 parallel tangents or one pair of parallel tangents. As such, if they want, see, there are infinite number of tangents. For every tangent, there could be one parallel tangent. So here the answer, they want to know a circle can have dash parallel tangents at most. So you can say 2 parallel tangents, or basically a pair of parallel tangents. A common point of a tangent to a circle, and the circle is called point of contact. It's called point of contact. Okay, coming to next. A tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O at a point Q, so that OQ is equal to 12 centimeter. Find PQ. Drawing for it. So there is a circle. Okay, a tangent PQ at a point P on the circle. So there is a point P on the circle where the tangent is coming. Yes. A tangent PQ at a point P of the circle of radius 5 centimeters. So this point is P. This is the center of the circle, and the radius is 5 centimeter. This is 5 centimeter. Meets a line through the center O at a point Q. So line through the center O, it is meeting here at Q. This is PQ. And center is O. Right? And we know that OQ is equal to 12. OQ is 12. Now, we know that the tangent meets at 90-degree angle. So that means it is a right angle triangle. When this is right angle triangle, we can the Pythagoras theorem will apply for it. So we can say OQ square, that is the hypotenuse square, is equal to PQ square plus OP square by Pythagoras theorem. So we can say 12 square is equal to PQ square plus OP is 5 square. So 12 square comes out to be 144 is equal to PQ square plus 25. So PQ square comes out to be 144 minus 25. That comes out to be 119. So PQ comes out to be square root of 119. So answer is square root of 119 centimeter. Okay, so coming to the next question. What does it say? Draw a circle and two lines parallel to a given line such that one is a tangent and the other is a secant of the circle. Okay, so we can draw it. Let's draw a circle and there's a line. We have to draw one tangent parallel to this. We can draw a tangent like this. Okay, and then we have to draw a secant. Secant is which will touch it two different places. See how to draw it in the exam when it will come. It is a construction related question. So you have to, from this point, from the center of the circle, you have to make a perpendicular to this particular line so that this becomes 90-degree angle. How to make it? If you know constructions, from this point, we'll take a distance which is more than the distance of the length, and it will cut here and cut here. And from here, we'll make a perpendicular bisector of it. When you make a perpendicular bisector from this point, we'll cut at 2 points, one here, and then on the other side also. And then we'll make a line to join these points. And then this will make a perpendicular bisector. With the perpendicular bisector, we will be able to, we'll get this point. And from this point, we'll make a tangent. So this on this point, basically, we'll make a 90-degree angle. And the other line also, we can just choose any point on the radius, make a 90-degree angle on that. So that will create a secant. Okay, it's a construction related question, or if it's a one marker question, then you can directly create it, because in this question, they wanted to just check whether you know the difference between a tangent and a secant on a non-intersecting line. They wanted to just understand this difference from you. Okay, next, prove that in two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. So there's a figure. They're saying that if there are two concentric circles, so here there are two concentric circles, C1 and C2. Concentric means, the word concentric means which has the same center. Two circles which has the same center will be called as concentric circles. The chord of the larger circle. So what is the chord of the large circle? AB. AB is the chord of the larger circle, which touches the smaller circle. So it is touching the smaller circle at P, is bisected at the point of contact. So what we have to prove? We have to prove that AP is equal to PB. This is what we have to prove. And how will we prove it now? So what we are going to do? We are going to join these 2 points, AB and, OA and OB. Now look at this triangle. If we look at the triangle, so in triangle OAP and OBP, OP is equal to OP. Common. Right? Now we'll say OA is equal to OB. That's the radius. Yes or no? And the third thing, that angle OPB is equal to angle OPA. 90-degree angle. Why 90-degree angle? That tangent subtends 90-degree angle at point of contact. So this is the point of contact. It subtends 90-degree angle. Now by these three are same, so triangle OAP is congruent to triangle OBP. Why they're congruent? By right angle, hypotenuse, side. So this is right angle, hypotenuse, and this side. So right angle, hypotenuse, and this side. So these are common. And when these are congruent, we can say that AP is equal to PB. And this is why corresponding part of congruent triangles are equal. Okay, so coming to next question. Okay, so this question states that two tangent TP and TQ are drawn to a circle with the center O from an external point T. Prove that angle PTQ, this angle is 2 times the angle OPQ, 2 times this angle. Okay, so we know that angle OPT is equal to 90 degree tangent. It's given as tangent. Okay, so OPQ is equal to 90 degree. So if I consider this angle as 1, this angle is 1. What is this angle? Or I am considering this angle as A. This angle is A. So the angle QPT is equal to, I can say it is 90 minus angle A, right? Similarly, angle PQT is equal to 90 minus angle A, right? Now angle T, which is angle PT, angle angle PTQ plus angle QPT plus angle PQT is equal to 180. So I have to find out angle PTQ. How much this comes? So PTQ plus, what is QPT? It is 90 minus angle A plus, what is angle PQT? It is 90 minus angle A is equal to 180. So if I take 90 to the other side and angle A to the other side, it becomes angle PTQ is equal to, this is 180 minus 90 becomes 0. And angle A becomes 2 times angle A. So this is what we had to prove. So it's a pretty simple thing. We can say that this angle is A. So this angle becomes 90 minus A. If this angle is 90 minus A, this angle is also 90 minus A. Why it is 90 minus A? Because TP is equal to TQ. Because both the tangents are equal, this angle will be equal to this angle. This angle will be equal to this angle. So both the angles are equal. Now, what is the angle? This angle is 90 minus A. This is also 90 minus A. So when we computed the angle T, this angle, when we computed T, at that time we found that it comes out to be 2 times the angle A. Okay, so coming to this question, it says PQ is a chord of length 8 centimeter of the circle of radius 5 centimeter. So the figure is given here. So PQ is a chord which is of length 8 centimeter and the radius is PO or OP, that is 5 centimeter. The tangents P and Q intersected point T. So there are two tangents PT and QT, they intersected point T. Find the length of TP. So you have to find the length of the tangent. What is the length of the tangent? That is, we have to find TP. Okay, so to compute that, there are certain things which you have to first identify. Now, so we are taking two triangles. The first triangle is PTO. This is the triangle we are taking. And the second triangle which you are taking is OTQ. This is the second triangle which you are taking. These are two triangles which you are taking, and we will prove these as congruent. So in triangle PTO and triangle QTO, okay, we can say OP is equal to OQ, radius. We can say that PR is equal to TQ. PR is equal to TQ. These are tangents. Tangents are equal from one point. If the two tangents which are made are equal, tangents are equal. And the third angle, we can say OPT, angle OPT. Angle OPT is equal to angle QT. This is the 90 degrees. Both are 90 degrees. So we can say that these two triangles are congruent. So I will say triangle PTO is congruent to triangle QTO. So these two triangles are congruent. What does it give us? That give us that angle POR, that means angle POR is equal to angle QOR. Okay, this angle is equal to this angle. It gives us this part. Okay, now this is by CPCT. Now we'll remember this part. We'll remember this part. Now we'll check two triangles, that is PRO. So in triangle PRO and triangle QRO. Now we are considering these two triangles, the smaller triangles. This triangle and this triangle. This triangle. Okay. We are considering these two triangles. Now in these two triangles, we can say that OR is equal to OR, that is common. Angle, OP is equal to OQ, radius. And angle POR, angle POR is equal to angle QOR. And that is from where we proved it. Okay, and so that means these two triangles, so triangle PRO is congruent to triangle QRO by SAS, side, angle, side. By SAS congruency, these two triangles are congruent. Earlier, the triangles were congruent by, that is also by SAS. Okay, so these two triangles are congruent. When these two triangles are congruent, what we can say? We can say that angle PRO is equal to angle QRO. But angle PRO plus angle QRO should be equal to 180. So what does it implies? It implies that angle PRO is equal to 90 degree. So this angle is 90 degree and this angle is also 90 degree, right? So this is what we have proved till now. So this is another thing which we should remember. There is also one more thing which we have proved, that PR is equal to RQ. And we know that PR plus RQ was, PR is equal to RQ because this is CPCTC again. So PR plus RQ is 8. That means PR is equal to 4 centimeter. PR is equal to 4 centimeter. So this part PR is equal to 4 centimeter. So I'll just write it as 4 centimeter. Now we'll take, it's a little lengthier computation. So we'll take triangle. So in triangle PRO, okay, it's a right angle triangle because we have already proved that this angle PRO is 90 degrees. So angle in triangle PRO, we'll say PO square is equal to PR square plus OR square, right? So PO square is 5 square is equal to 4 square plus OR square. So from here, OR comes out to be 25 minus 16 OR square. So OR is equal to square root of 9. That comes out to be 3. So OR, the value comes out to be 3. And I consider TR as X. If I consider TR as X, this is another thing. Okay, we are considering TR is equal to X. Now, there is one more triangle here, which is the right angle triangle, that is PTR. This is the right angle triangle, PTR. Right? So in this, in triangle PTR, we can say that PT square is equal to 4 square plus x square. Yes or no? Because it's a right angle triangle. And in triangle, if I take a bigger triangle, that is PTO. If I take a triangle PTO, I can say, because it is also right angle at P, this is also right angle 90-degree angle. The tangent is this is a 90-degree angle. So we can say that 3 plus x square, 3 plus x whole square, this is the hypotenuse, is equal to 5 square plus PT square. So from this and this second, so I'm putting the value from here to here. So it becomes 3 plus x whole square is equal to 5 square plus 4 square plus x square, right? So it is just open the square here. So it becomes 9 plus x square plus 6x is equal to 25 plus 16 plus x square. Now this x square will get cancelled by x square, and here it becomes 25 plus 16. So 25 plus 16 is equal to 25, 35, 40, 41, and 41 minus 9. 41 minus 9 comes out to be 32. 6x is equal to 32. So x comes out to be 32 divided by 6, and I'll divide it by 2. 3 is a 6, 2, 16. So it comes out to be 16 divided by 3. So the value of x is 16 divided by 3. This is the value of x. Now, we'll put this value in any of the equations to find the value of PT. So we'll put in this value in this equation. So I can say PT square is equal to 4 square plus the value of x is 16 by 3. So I'll just say 16 by 3 square. So PT square comes out to be 16 plus 256 by 9. PT square is equal to 16 multiplied by 9 plus 256 by 9. So it comes out to be 16 multiplied by 9 is 144. 144 plus 256 is 400. It becomes 400 divided by 9. So PT comes out to be square root of 400 by 9. That is equal to 20 divided by 3. So the PT, the length of the tangent, is 20 divided by 3. That's the right answer. Okay, from a point Q, the length of the tangent of a circle is 24 centimeter and the distance Q from the center is 25. The radius of the circle is, so we have to find the radius of the circle. Let's draw a circle. Center is O. There is a point Q outside, and we'll make a tangent from Q, which is touching at point, say, P. And they have given QP as 24, and will be join this. And this is the radius. And they have given OQ as 25. Now we know that OPQ is a right angle triangle. Right angle triangle. Why is it right angle? Because angle P is 90 degree. The tangent makes an angle of 90 degree at point of contact with the radius. Right? So this is a right angle triangle. With the right angle triangle, we can say that OQ square is equal to PQ square plus OP square. That is radius square. So OQ square is how much? OQ is 25 square is equal to 24 square plus radius square. So from here it comes as radius square comes out to be 25 square minus 24 square is equal to 625 minus 576. And when we subtract it, it comes out to be 49. So radius is equal to square root of 49. That comes out to be 7. So 7 centimeter is the right answer. So radius is equal to 7 centimeter. So coming to the next question. In figure, so there's a figure which is given. In figure, TP and TQ are the two tangents, okay, to a circle with center O, so that angle POQ is equal to 110. This angle is equal to 110. Then we need to find the angle PTQ. PTQ is this angle. We have to find, this is our question mark. This is the question mark. See, it's a pretty simple question. We know that the tangents make an angle of 90 degree. Tangents make an angle of 90 degree. And we also know that in a quadrilateral, the sum of four angles is 360. Isn't it? So this is 90. This is 90. So we can say 110 plus 90 plus 90 plus angle T plus angle T is equal to 360. Okay. So angle T, if you compute it, it is 90, 90, 180, 180 will cancel out. 110 plus 70. So angle T will come out to be 70 degrees. 70 degrees. This angle comes out to be 70 degrees. So this is the right answer. Coming to next question. If tangents PA and PB from a point P to a circle with center O are inclined to each other at an angle of 80 degrees. Is the figure given? No, it's not given. So they are saying that there is one circle and there are two tangents. There are two tangents. One tangent is this. Another tangent is this. Okay, so this is one point of contact. This is another point of contact. And they have an angle of 80 degree in between. So this is P, A, B, and this point, center O. Then find POA. So we have to find POA. We have to find this angle. So we just join it. Join this angle. Okay, you have to find POA. Okay. See, we know that triangle POA and triangle POB. Okay, they are congruent. Okay, these two triangles are congruent. We can prove it through multiple ways. Okay, either we can prove it through RHS or we can prove it through SAS. Okay, so this side is equal to this side. This side is equal to this side. 3 and I made 4, so I'll just make 4 here. And the side PO is common. Side PO is common. So I'll just say OA is equal to OB, radius. Then I'll say OP is equal to OP, common. Common. Then I'll say PA is equal to PB, tangents to a circle from a point. Tangents. So these two triangles are congruent. So triangle POA is congruent to triangle POB. What does it mean? This means that this angle is equal to this angle. So angle OPA is equal to angle OPB. Okay. So, but this OPA, but angle OPA plus angle OPB is equal to 80. So we can say angle OPA is equal to 40 degrees. So we know that this angle is 40 and this is also 40. We know this angle is 90. So when we know two angles, we can find the third angle easily, isn't it? So I can say angle POA is equal to 180 minus 90 minus 40. So this will give me an answer of POA is equal to 50 degrees. Angle POA is equal to 50 degrees. So this angle, this is the right answer. So coming to next question. It says, prove that the tangents drawn at the ends of a diameter of the circle are parallel. Is the figure given? No, the figure is not given. So let's make a circle. This is the circle we are going to make. And we'll make one tangent at this point. And we'll make a diameter Diameter passes through the center, and we'll make a tangent at this point. They're saying we need to prove this is parallel. So we can say this is O. We'd say this point is A, this point is B. See, this angle is 90 degree. We know that. We know this angle is also equal to 90 degree. Okay, but they form a pair of alternate interior angles. They form a pair of alternate interior angles. And that's why the line L1 is parallel to line L2. So we have to write that. We have to write all these things. That this angle OAM, is equal to angle OBN. Okay, but they form a pair of alternate interior angles. And because they form a pair of alternate interior angles, line L1 is parallel to line L2. Okay, so coming to the next question. Prove that the perpendicular at a point of contact of the to the tangent to a circle passes through the center. Okay, so this is a good question. Figure is not there, so I'll just make it. Let's make a circle here. They're saying that there is a tangent here. And they're saying at this point, we are making a perpendicular. We are making a 90-degree angle. Okay, and they're saying that we have to prove that it passes through the center. So this is O. We'll just say this is P. So let's assume that it does not pass through center. Let's assume that this does not pass through center, and this is the point which say where this is the line which is not passing through center, and it is a perpendicular. It's a perpendicular. So I'll just say this point, say M. So they are saying MP. I'll just write, say Q. Say MPQ is equal to 90 degree. We consider that MP is perpendicular. Consider MP is perpendicular to tangent. So angle MPQ is equal to 90 degree. Okay, this is where we have assumed MPQ is equal to 90 degree. But we know that OPQ is equal to 90 degree. Okay, why? Because the tangent makes an angle at the center. Okay, at the point of contact. So we know OPQ is equal to 90 degree. That means, what does it mean? That MP and OP are the same line, are on the same line, or on same line, are on same line. So this, we have to write here a little. You have to write here a little in this question. Okay, coming to the next question. It says the length of a tangent from point A at a distance of 5 centimeter from the center of the circle is 4 centimeter. Okay, so let's make a circle here. Figure is there? No. So let's make a circle here. The length of a tangent at point A. So this is a point A at a distance 5 centimeter from the center of a circle is 4 centimeter. So this is the length of the tangent is 4 centimeter. This is 4 centimeter from, say, point, I'll just say P. This is A. And this point they're saying is 5 centimeter away from the center. So this is the center O. They're saying this is 5 centimeter away from the center. 5 centimeter from the center of the circle is 4 centimeter. And we need to find the radius. This is R. So we know that OP square is equal to PA square plus OA square. That gives us 5 square is equal to 4 square plus R square. So R square comes out to be 5 square is 25 minus 4 square is 16. That comes out to be 9. So the value of R comes out to be square root of 9. That is equal to 3. So R is equal to 3 centimeter in length. It's a pretty simple question just for you to check that this angle makes the angle of 90 degree. And that is why the Pythagoras theorem will apply for this question. Okay, coming to next question. Two concentric circles of radii 5 centimeter and 3 centimeter. Find the length of the chord of the larger circle which touches the smaller circle. So we did this kind of question in our examples earlier. So there are two concentric circles. So there are two circles which are given. The radius of the bigger one is 5 centimeter and the radius of the smaller one is 3 centimeter. Okay. Now we need to find the length of the chord. We have to find the length of the chord. So now we know the triangle OAP. Triangle OAP is a right angle triangle at P, right? So if it's a right angle triangle at P, I can say that OA square is equal to OP square plus AP square. So that means 5 square is equal to 3 square plus AP square. So AP square comes out to be 5 square is 25 minus 3 square is 9. It comes out to be 16. AP square. So from here, AP comes out to be square root of 16. That comes out to be 4. So we know AP is equal to 4. But we also know that this we proved earlier that AP is equal to PB. We proved it earlier in some question. Okay, so AP is equal to PB. So we can say this is 4 and this is 4. So the length of chord AB will be, so we can say AB is equal to 4 plus 4. That comes out to be 8 centimeter. So the length of the chord of the larger circle is 8 centimeter. So coming to the next question, it says a quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. From one point, if you are putting two tangents, both the tangents will be equal. So we can say here that DS is equal to DR, isn't it? We can say SA is equal to AP. Okay. And we can say BQ is equal to PB. Similarly, we can say CQ is equal to RC. Isn't it? So let's add, because these are two tangents from the same point D. These are two tangents from point S. These are two tangents from point B. And these are two tangents from points C. It has to be equal. Now, if we add all sides, so we are adding, so it becomes DS plus SA plus BQ plus CQ is equal to DR plus AP plus PB plus RC, right? So DS plus SA, we can write it as DA, DA, and BQ plus CQ, BQ plus CQ, we can write it as CB. That is equal to, when I say DR plus RC, DR plus RC is CD, and AP plus PB. So when we say AP plus PB, it is equal to AB. Or we can say that AB plus CD is equal to AD plus BC. So this is something which you had to prove. This is something which you had to prove. So we can write the same thing again. That means that gives us AB plus CD is equal to AD plus BC. Okay. Okay, so coming to this question, it says in figure X, Y and X dash Y dash are the two parallel tangents to a circle with the center O. And another tangent AB, this is AB. AB with point of contact at C intersecting XY at A, XY at A, and X dash Y dash at B. Okay. Prove that AOB is equal to 90. So we have to prove that this angle AOB is equal to 90 degree. So to prove that, what we're going to do, I'll just first clear it up. So we'll take two triangles. In triangle POA and triangle AOC. AOC. We know that PO is equal to OC. We also know that OA is equal to OA, common. This is radius. And we also know that AP is equal to AC. The tangents are equal. Tangents from an external point to a circle are equal. So these triangles are congruent. You can say triangle POA is congruent to triangle AOC. So what does that mean? That means angle POA is equal to angle COA. So that means this angle is equal to this angle. Okay, this is by CPCTC. That is, congruent part of congruent triangles are congruent. CPCTC. So if this is 1, this is 1. Similarly, angle COB is equal to angle QOB. Okay, so we can say if this is 2, this is also equal to. So, but we know that angle POA plus angle COA plus angle COB plus angle QOB is equal to 180. Is equal to 180 because it's a straight line. It will make a straight line. So we can say angle 1 plus angle 1 plus angle 2 plus angle 2 is equal to 180. So we can say 2 times angle 1 plus 2 times angle 2 is equal to 180. Angle 1 plus angle 2 is equal to 90 degree. Or we can say that angle AOB is equal to angle 1 plus angle 2, and that is equal to 90 degree. So coming to the next question, it states that prove that the angle between the two tangents drawn from the external point to a circle is supplementary to the angle subtended by the line segment joining the points of the contact at the center. See, line segment joining the point at the center. So this is line segments joining the point. Okay, line segment joining the points of contact. So these are the point of contact. A and B are the point of contact. So line segment joining the point of contact is A, B. So they are saying angle AOB plus angle P. This should be equal to 180. So they want to prove that angle AOB plus angle APB is equal to 180. This is what you have to prove. So we can say, so in quadrilateral AOBP. Okay, there are 4 angles. The 4 angles is angle OAP plus angle AOB plus angle OBP plus angle BPA is equal to 360. But we know that angle OAP and angle OBP are 90 each because they are the tangents. This angle is 90 and this angle is 90. So we'll say angle AOB plus 90 plus angle BPA is equal to 360. So angle AOB plus angle BPA comes out to be 360 minus 90 minus 90. That is 360 minus 180. That comes out to be 180. So this is what we had to prove. So angle APB or angle BPA is one and the same thing. So this is what you have to prove. Okay, so coming to the next question. Prove that the parallelogram circumscribing a circle is a rhombus. Okay, so it's a parallelogram. So what is given to us? Given to us is that DC is parallel to AB and DC is equal to AB. This is given. On the other side, it is given that AD is parallel to BC and AD is equal to BC. Oh, this is given. Given why? Because it's a parallelogram. They have mentioned that ABCDs are given as ABCD is a parallelogram. Okay, so now we have to prove that this parallelogram is a rhombus. Now, what is a rhombus? What is a rhombus? To prove it is a rhombus, we need to prove that all the sides are equal. Now we know that opposite sides are already equal. It's a parallelogram, opposite sides are already equal. So if we are able to prove that DA to prove that ABCD is a rhombus. And for that, what we will do? We'll say that we'll prove that AD is equal to DC. This is, if we prove, we can say that it's a parallel, it's a rhombus, because we know that AD is already equal to BC. AD is already equal to BC. Now, if AD is also equal to DC, which is equal to AP, that means all four sides are equal. That means it is a rhombus. So this is what we are going to prove. Okay. Now, how will you prove it? Now, we can say that AP is equal to AS, right? And right, we can say that SD is equal to RD, right? And PB is equal to QB. And we can say that RD we wrote this side. So RC is equal to CQ, right? Why this is equal? Because all four are the tangents. Tangents from an external point to a circle, from an external point to a circle are equal. So you have to write these theorems. Okay, these theorems you have to remember, which you have to write. Now, if we add all these, it becomes AP plus RD plus PB plus RC is equal to AS plus SD plus QB plus CQ. Now, if we say AP plus PB, what is AP plus PB? This gives me AB. So I can say this is AB plus RD plus RC. RD plus RC is, I can say DC, or I can say CD. AB plus CD is equal to, AB plus CD is equal to, now AS plus SD. So AS plus SD will give me AD plus, now QB plus CQ. QB plus CQ will give me BC. Right? But we know that AB is equal to CD and AD is equal to BC. Isn't it? Why? Opposite sides of parallelogram. Opposite sides of parallelogram. So we can say that AB plus AB, I can say 2 times AB is equal to 2 times CB, BC, we can say. So that means AB is equal to BC. So we are able to prove that this side is equal to this side. And we already know that BC is equal to DA, and we know that AB is equal to DC. So that means all four sides are equal. So all four sides are equal. Therefore, ABCD is a rhombus. Okay. So coming to this question, it says that the triangle ABC is drawn to circumscribe a circle of radius 4 centimeter such that the segment BD and DC, into which BC is divided by the point of contact D, are of lengths 8 centimeter and 6 centimeter respectively. Find the side AB and AC. Okay, so this is the question here. So we have to find AB and AC here, the two sides of the triangle. Now, see, this question is a little different question than the other questions, and in which, first of all, I'll just make this point. This is M and this is N. Now we know that CD is equal to CM. So this will be 6. And DB is equal to BN. So this will be 8. And why that will be because from one point, if you make two tangents, the length of the tangents is same. So that's why it is same. Now, if I say AM is equal to X, then AN will also be equal to X. Now, see, this question requires to be done in a different way. So where we'll be finding the area of this entire triangle in two different ways. Okay, using the Hero's formula and the other formula, which is half base into height. And then we will be able to find out the value of X. And with the help value of X, we will be able to find the value of AC and AB. So let's start this question here. So we know that the area of a triangle is equal to square root of S into S minus A into S minus B into S minus C. So this is called Hero's formula. Okay, and what is S? S is equal to A plus B plus C divided by 2. So think as if this side is A. This complete side is A. This complete side is, say, B. And this complete side is, say, C. Okay. So when we have the three sides given, this is the formula which is used to find the area of a triangle. Okay. So now let's just find the value of S. So S is equal to, we know it is, let's say A, it is 6 plus X plus B, 8 plus X plus C is 6 plus 8. 6 plus 8 is 14. So that comes out to be divided by 2. I have to say divided by 2. So this value comes out to be 14 plus 6, 20, 28 plus 2x. 28 plus 2x divided by 2. So if we divide it by 2, it comes as 14 plus x. So this is the value of S. Now putting the same thing in the formula. So area is equal to, I'm writing it small because I know this is a lengthier question. The computation is a little longer. So 14 plus x, this is S into S minus A. So it is 14 plus x minus A, 6 plus x multiplied by, bracket close. It is 14 plus x minus B. B is 8 plus x into 14 plus x minus C. C is 14. So if I compute this, this comes out to be square root of 14 plus x. See, if I open this part, x will cancel out with x. It becomes 14 minus 6, that is 8. This x will cancel out with x. 14 minus 8 is 6. And here it is 14 will cancel out. X will remain. Okay. Now this value comes out to be square root of So if I take out the, if I just factorize it, it becomes 14 plus x. I write it as 2 into 2 into 2 as 8, and 6x is 2 into 3x. So out of these two, one will come out. Out of this two, one will come out. So the value comes out to be square root of 4 will come out. So this is 4, 14 plus x into 3x. And the value equals here 4, 4 square root of 3x into 14. 14 3 is 42. 42x plus 3x square. So this is the area. This is the area by Hero's formula. Heron's formula. Okay, Hero's formula, we say it is Heron's formula actually. Okay, now we'll find the area using a different method. Different method is we'll divide this entire ABC triangle into 3 different triangles. So we'll just join this part and join this part and join. So we'll join center with all 3, and we'll join M with O, O with N, and the third one is given. And the radius is already given as 4. This is 4. This is 4. So let's find the area of AOB. So area of AOB, triangle AOB. I should write triangle AOB. Area of triangle AOB. This will come out to be half into base. Base is 8 plus x. And height is 4. Why are we taking height? Because this is making a 90-degree angle here. So into 4. So this value comes out to be, if I cut with 2, so it comes out to be 16 plus 2x. Now area of AOC, triangle AOC, is equal to half into base. Base is 6 plus x into 4. So 2 will cancel out with 2 again. So it becomes 12 plus 2x. Then area of BOC is equal to half into, it is 8 plus 6, 14 into 4. So it comes out to be 28. And if we take the area of all three together, total area. So area triangle ABC is equal to the sum of all 3. So sum of all 3 is 16 plus 2x plus 12 plus 2x plus 28. And this value comes out to be 16. So 28 plus 12 is 40. 40 plus this is 56. 56 plus 2x plus 2x, 4x. So this is also the area of the triangle. Now, both the areas should be equal because we have computed the area, and area of the triangle should be same, whether we calculate through one way or the other. So 4 square root of 42x plus 3x square should be equal to 4x plus 56. So this is first equation and this is second. So from 1 and 2. So I can say from 1 and 2, from 1 and 2. From 1 and 2, this is the value which comes out. Now we can divide the entire equation by 4. So it comes as 42x plus 3x square is equal to x plus, so 4 1s are 4, 4 4s are 16. Discuss square root. Now squaring both sides because we have to remove the square root. So it becomes 42x plus 3x square is equal to x plus 14 square. So I'll just say x square plus 14 square is 196 plus 2 AB. 2AB is 2 into 14, 28x. Now if I move everything to one side, it becomes 2x square minus x square is 3x square minus x square is 2x square. 42 minus 28, 28, 38, 14. So it becomes plus 14 x square, sorry, 14x, that's x. I just clear and write it. 14x minus 196 is equal to 0. Now dividing the entire equation by 2, it becomes x square plus 7x minus 2 9s are 18, 2 9s are 18, and 2 8s are 16, 98 is equal to 0. Now it's a quadratic equation and we should solve it by any of the methods. So the one method which we know is splitting the middle term. So let's split the middle term. Let me just find out what are the factors. Factors of 98 is 2, 2 4s are 8, 2 9s are 18, 7 and 7. So I can say 14 and 7. So it becomes x square plus 14x minus 7x minus 98 is equal to 0. So from here, we can say x common, x plus 14 minus 7 common, it becomes x plus 14 is equal to 0. So this gives us x plus 14 common here, x plus 14, then x minus 7 is equal to 0. So there are two values which came. This x is equal to minus 14 and x is equal to 7. See, minus 14 is not possible. This is not possible. So x is equal to 7 is the value. So if x is equal to 7, I'll just put the value here. X is equal to 7, x is equal to 7. So what is AB? So AC is equal to x plus 6. So it is 7 plus 6. 7 plus 6 is 13. And what talk about AB equal to x plus 8, that is equal to 7 plus 8, that comes out to be 15 centimeters. So 13 centimeter and 15 centimeter is the size. Okay, so coming to the next question. It says, prove that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Okay, so the figure goes like this. So they want to know the opposite sides of the quadrilateral. So these are the opposite sides. Let's say this side is subtending some angle at the center. So this is one angle and this is one angle. So they are saying the sum of these two angles should be 180 and sum of this angle plus this angle should be equal to 180. So I'll just write it. I just clear it up and write to prove that angle DOC plus angle AOB is equal to 180. Okay, when we talk about say supplementary means the sum of the angles is 180. This is first thing we have to prove. The second thing on the opposite side is COB, angle COB plus angle DAOD or DOA is equal to 180. This is second thing which we have to prove. Okay, these are two things which you have to prove. Now to prove this, what we're going to do is say we know, so we'll take any of the triangles. So let's take triangle ROC, this triangle, and COQ, this triangle. Let's take these two triangles. Okay, in triangle ROC and triangle QOC. Okay, we know that RO is equal to QO, radius. So radius is always of a circle is same. Now OC is equal to OC. That is common. It's a common side of the triangle. Then we know CR is equal to CQ. Okay, why is it? Because tangents from one point, tangents from one point to a circle are equal. Both the tangents from one from external point to the circle are equal. Okay, so these two triangles are congruent. So we can say that triangle ROC is congruent to triangle QOC. So these two triangles are congruent. So when these two triangles are congruent, what does it mean? That means that this angle will be equal to this angle. So we can say angle ROC is equal to angle COQ. Okay, by CPCTC. That is, congruent part of congruent triangles are congruent. Congruent part of congruent triangles are congruent. Okay, now, so if I consider this as 1, similarly, this angle I'll consider as 2. This will be equal to 2. Similarly, if I consider this angle as 3, this angle will also be 3. Similarly, if I consider this angle as 4, this angle will be 4. Isn't it? So we can say that angle 1, basically angle ROC. So we can write all 8 angles here. All 8 angles. This is 1, 2, 3, 4, 5, 6, 7, 8. All 8 angles here. And the sum of all the angles will be equal to 360. So I'm writing all the angles here. So angle DOR plus angle ROC plus angle COQ plus angle QOB plus angle BOP plus angle POA plus angle AOS, plus angle SOD should be equal to 360. So what is DOR? DOR we have considered as angle 4. Angle 4 plus angle 1 plus angle 1 plus angle 2 plus angle 2 plus angle 3 plus angle 3 plus angle 4 should be equal to 360. So I can say 2 times angle 1 plus angle 2 plus angle 3 plus angle 4 should be equal to 180. And I can say that angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to, this should be 360 and this should be 180. Angle 1 plus angle 2 plus angle 3 plus angle 4 should be 180. And so when we are able to prove this, okay, this thing to be noted. Now we have to prove the opposite sides. So it is 1. So if I say angle DOC, so angle DOC is what? So we have to prove angle DOC plus angle AOB is equal to 180. This we have to prove. Okay. Now what is angle DOC? DOC is angle 4 plus angle 1. Right? Plus angle AOB. AOB is angle 2 plus angle 3. And we know that this is equal to 180. Similarly, angle COB plus angle DOA is equal to 180. Okay. Okay, so let's come to the next question then. Oh, so finally our exercise got over. So this finishes the chapter. Okay, but we'll be discussing some more questions in the coming exercise, as well as before your exams, I'll be publishing few more questions, which are important questions, which can come in exam. So please go through my further videos and subscribe to the channel so that you are notified of any video which is getting uploaded. Okay, so happy learning. Enjoy your day. Bye-bye. Take care.